Here we are looking at ratios, proportions, and similar figures. This one's going to focus more on the similar figures and the similar polygons. To be similar in similar polygons, it's two polygons are similar if corresponding angles are congruent. So that's a big one right there. Corresponding angles must be congruent. And then the lengths of the corresponding sides are proportional. When we say corresponding sides, we're thinking of the matching sides and the matching angles to each other that relate to each other. So looking at this diagram, I can see, here's my similarity statement. A corresponds to G, B corresponds to H, C corresponds to I, and C corresponds to I, D corresponds to J. So on each of these angle measures, you can see that they also match B to H, C to I, D to J. Those angles must be congruent. That's step one. The second part to being similar is that those corresponding side lengths are proportional. So this side length of AB we can compare to GH as a ratio. BC over HI should equal that same ratio. CD, which corresponds to IJ as a ratio, that should equal the other two. And then AD, this bottom part, and GJ as a ratio should equal the rest of those other three sides as well. All right, and we use this little squiggle symbol to represent similarity. The other vocab term we're going to look at is something called a scale factor. It's the ratio of corresponding linear measurements of two similar figures. When we find these ratios here and we find that they're all equal, they will have a scale factor. So let's look at the first example. Are the polygons similar? If they are, write the similarity statement and determine the scale factor. So we need three things here. Are they similar? If they are, we're going to write a similarity statement and we're going to determine the scale factor. So three different things here. First, let's identify pairs of congruent angles. So I'm going to start with M, and I can see it's congruent to W. So angle M is congruent to angle W. Angle J is congruent to angle T. Whoops, I wrote that a little backwards. There we go. And let's just take a moment and fill the rest of this out. All right, so there's the 4. 1, 2, 3, 4, 1, 2, 3, 4, and they all correspond to each other. So there's that first part. They are congruent to each other based off of our congruent arcs there. All right, so the second part, compare the ratios of corresponding sides. Sometimes in the past I've had students do different things where they might circle the corresponding parts. They might choose different colors like I'm going to do right now. Let's just choose a color right here. So MJ, that corresponds to WT. So I wrote this a little out of order, I'm sorry. JK, TU. JK was 12, TU was 6. So if I were to simplify that, that would be 2. KL corresponds to UV. So 24 over 16. If you were to simplify that, you can simplify this in a couple ways. We could divide these by 2, we could divide them by 4, we could divide them by 8, right? 8 would be a good choice. I could divide each of these by 8 to be 3 over 2. Right away, that's not going to be the same ratio, but let's continue on. LM corresponds to VW, so 24 over 14. I can't divide each of these by 8, but I can divide them by 2, so I'd get 12 over 7. Again, not the same ratio. And then the last one, I skipped ahead and did this one already. It would be JM and TW, 6 over 6, but that's not going to correspond, so that does not match. We can write right here, corresponding sides are not proportional. The polygons are not similar. This is an example of not similar because they're not the corresponding sides are not proportional. But let's take a look at the next example. Let's first identify the congruent angles. So angle C is congruent to angle F. Angle A is congruent to angle D. And angle B is congruent to angle E. I'm going from left to right each time. You want to stay consistent which direction you're going in as you're doing these. And that'll affect your corresponding sides as well. So let's take a look at the first one. AB corresponds to DE. So 12 over 15. Sometimes I get the question of like, how did I get that corresponding side? Like you don't see it when you're rotating the paper. One of the things that I noticed is that if I see the congruence markers for the angle measures, you can see that this one between A and B is a 2 and a 3 for the arc. So you want to look on this one, which one has 2 and then 3. So you can see it's from D to E. So this would simplify. We could divide this by 3 to get 4 over 5. Let's try the next one. BC goes from a 3 congruence arcs, the arcs there, to 1. So over here it'd be 3 to 1. That corresponds with the 20. 16 over 20. If you were to divide each of these by 4, you get 4 over 5. We're looking good so far. And then this last one, AC over DF is 8 over 10. If you were to divide each of these by 2, you would get 4 over 5. So hey, look at that. They are all the same, right? They are proportional. All those ratios are congruent. So, because they are similar, just write similar, yay. Because they're similar, we can write what we call a similarity statement. Now, this similarity statement is one that can be different for depending on where you start. I'm going to go from left to right. So I'm just going to say triangle A, B, C. Oops, I almost wrote the congruent symbol. Similar. If I did from A to B to C, I have to be very careful here. My next triangle that I write for the similarity statement has to be the matching angle that I started with, A. And remember, A was congruent to D, so I'm going to start with D. B corresponded to the E, it was congruent to E. So I'm going to do D, E, and then C and F would match. You could have written a similarity statement like this instead. Could have said triangle BCA is similar to triangle EFD. That would have worked. You could have said triangle CBA. And if you say CBA, it would be FED, right? All of those similarity statements work as long as you are matching the corresponding parts, right? So I could look at this statement and say C to F, right? C to F, B to E, B to E, A to D. But then I can also look at the segments and say CB and FE correspond to each other. CB and FE, right? They correspond to each other. So the similarity statement is kind of your choice depending on what you started on in that first statement. So this is what we call our similarity statement. Okay, so the last part, our scale factor. If I'm going from ABC to DEF, that's going from this figure to this figure here, the left to right. And so I was doing that already with my corresponding sides, so my scale factor is actually going to be pretty quick here. Scale factor, the numerators were our left figure, the denominators was the right. So I can write my scale factor as 4 to 5. The smaller figure to the larger figure, 4 to 5. If I had written my similarity statement the other way, so if I had written this as triangle, let's say DEF is similar to triangle ABC, then the scale factor would have been written as 5 to 4. If you have further questions and you're following along on the document, you can always click this link and it'll send you to another helpful video. This is it for Similar Polygons. If you have any questions, let me know.